Today we are going to see how laser works. Myself, Suvarna Kshirsagar from NKOCET Solapur. Laser is an acronym which says light amplification by stimulated emission of radiation. To see the working of laser, three quantum mechanical processes: stimulated absorption, spontaneous emission, stimulated emission, and the concept of population inversion should be known. First, we will see what is meant by stimulated absorption or absorption. Initially, all the atoms they prefer to remain in ground state in order to acquire minimum potential energy. But if we will supply external energy, maybe in the form of light, electrical field, then atoms in ground state absorb the energy and excite to the higher energy state. The process is known as stimulated absorption. Second quantum mechanical process is spontaneous emission. Atoms in higher energy state will not remain for longer time because lifetime of higher energy state is very small, it is in nanoseconds, and they will do downward transition on their own. The process is known as spontaneous emission. Atoms decay from level 2 to level 1 through the emission of photon with a energy h nu, which is difference of two energy states E2 minus E1. It is a completely random process. Third process is stimulated emission. Atoms in upper energy level can be triggered or stimulated in phase by an incoming photon of specific energy h nu, which is also equal to E2 minus E1. This incoming photon will trigger atoms in excited state come down simultaneously to the ground state. Emitted photon is having all properties same as that of the incident photon. So emitted photon and incident photon, they are in same phase, they are emitted in same direction. Since they are in same phase, they add in phase and finally intensity is increased. Their state of polarization is same, they are coherent, and therefore we can say stimulated emission have unique properties over the spontaneous emission. Stimulated photons are in phase with incident photon. They have same wavelength as the incident photon, travel in same direction as the incident photon, and therefore they add up and gives rise to a very high intensity, that is light amplification. To get light amplification, what is necessary is atoms in excited state must be large in quantity. This is known as population inversion. It is the state in which a substance has been energized or excited to a specific energy levels. More atoms or molecules are in higher excited state. This population inversion can be produced by the process of pumping. Pumping is the process in which atoms in ground state are brought to the higher energy state by supplying external energy, maybe in the form of light or lamps of appropriate intensity or by electrical discharge. What are the common components of all lasers? First requirement, first component of laser is active medium. The active medium may be in solid, liquid or gaseous form. The active medium may be in solid form such as ruby or NdAg, liquid dyes or gases like carbon dioxide or helium neon, or semiconductors such as gallium arsenic. Active mediums contain atoms whose electrons may be excited to a metastable energy level by an energy source. Metastable energy state is higher energy excited state whose lifetime is 10 raised to minus 3 or 10 raised to minus 6 seconds. And therefore, in metastable energy state, atoms can remain for longer time as compared to the usual excited state. The second component of laser is excitation mechanism. Excitation mechanisms pump energy into the active medium by one or more of three basic methods: optical, electrical or chemical. The third component of laser is high reflectance mirror, a mirror which reflects essentially 100% of the laser light. And the fourth one is partially transmittive mirror, a mirror which reflects less than 100% of the laser light and transmits the remainder. The high reflectance mirror and partially transmissive mirror together can be called as optical resonator system. Thank you.